Cosmic Brief, your guide to the universe.
Earth's atmosphere currently contains about 21% oxygen. That number is not random. It is the result of billions of years of biological production and chemical balance. Life as we know it evolved under this concentration. Now imagine a sudden planetary shift where atmospheric oxygen does not disappear, but doubles. 42% oxygen. At first, breathing feels easier. Higher oxygen partial pressure allows more efficient transfer into the bloodstream. Physical performance temporarily improves. Fatigue decreases. High-altitude environments become easier to tolerate, but this benefit hides deeper instability. Fire behavior changes immediately. Oxygen is the primary driver of combustion rate. With double concentration, ignition thresholds drop. Materials that are normally hard to burn ignite more easily. Small sparks start larger fires. Flame temperatures rise. Fire spreads faster and becomes harder to control. Wildfire risk explodes globally. Dry regions become extreme fire zones. Lightning strikes trigger massive burn events. Firefighting tactics must change because suppression becomes more difficult when combustion efficiency is higher. Industrial safety becomes critical. Factories, refineries, and chemical plants operate under strict oxygen assumptions. Higher oxygen increases explosion risk in many processes. Safety margins shrink. Static discharge becomes more dangerous. Human biology does not scale linearly with oxygen. Long-term exposure to high oxygen concentrations can damage lung tissue and increase oxidative stress inside cells. Oxygen is essential, but also chemically reactive. More oxygen means more free radical formation. Aging and cellular damage processes accelerate. Now consider insects. In prehistoric eras, when oxygen levels were higher, insects grew larger because their respiratory systems rely on passive diffusion. Higher oxygen supports bigger body size. Over generations, average insect size could increase. Ecosystem balance shifts. Ocean chemistry also responds. Higher atmospheric oxygen dissolves into surface waters. That alters oxidation reactions and microbial balance. Some species benefit, others decline. Biogeochemical cycles adjust. Aircraft performance changes slightly. Engine combustion efficiency increases because oxygen supply is higher, but overheating and material stress risks also increase. Sound travels differently. Air density changes modestly with composition shifts, slightly altering acoustic propagation characteristics. Not dramatic, but measurable. Athletics transform. Endurance performance rises short-term due to higher oxygen delivery, but long-term tissue stress increases. Medical adaptation becomes necessary. There is also climate interaction. Fire frequency increase injects more aerosols and carbon into the atmosphere. That feeds back into temperature and cloud formation patterns. The key insight is balance. Too little oxygen and complex life struggles. Too much oxygen and combustion and oxidation risks dominate. Earth's current level is a narrow operating window between starvation and overreaction. Oxygen is life-enabling, but in excess, it is destabilizing. Double it, and the planet becomes more energetic, more flammable, and biologically more stressed.